Hello. The theme for today's lesson is the Earth's waters. Water is a precious resource for life. You know that if there is no water, there is no life. So whatever water we have, we need to conserve, we need to be wise in using it, and we should take a pledge today before we start the lesson that we will conserve the water we have on the planet of this earth. Well, what are the sources of water we have? Almost 6 times more abundant. Water is almost 6 times more abundant than most other minerals within about 6 kilometers of the Earth's crust. Well, water is a mineral, is that right? Now, it is no surprise that water covers about 70% of the Earth's surface. Water is an abundant source, but is fresh water abundant? So, is there a real need to conserve water? The answer is yes, there is real need to conserve water. About 98% of all the water on the surface exists as liquid, and about 2% exists as snow and ice at various parts of the earth. Most of the ice are concentrated as ice caps at the poles. 97% of the Earth's waters are actually stored in the oceans, which contains high levels of dissolved salt, and water in the ocean is therefore called saline water. You see, saline water is not very useful to us because you cannot use it for drinking, you cannot use it for watering your plants, you cannot grow crops in that water. So saline water is there, a lot of it, but it is not very useful to us. Well, all other water which is good for human consumption and agriculture is what we call fresh water. So most of our discussion will be concentrating on the fresh water resources and how do we make use of the fresh water resources we have. Now, I have an illustration here of all the water that we have on the surface of the earth. Now, here is all the earth's waters. Of all that water, 97% is saline water in the oceans, and only 3% is fresh water. Well, if you take that 3%, what are the various components of that? Now, of that 3%, 68.7% are locked up in ice caps and glaciers at various parts of the world. About 2/3 of the Earth's fresh water supply is actually locked up in ice caps and glaciers at the poles. Now, 30% of the fresh water is actually underground, and that is available to us in locked up, is that right, reservoirs, and we can use them whenever we want it. And all the other fresh water resources, can you tell me what are some of the other fresh water resources? Well, the lakes and rivers and streams and all those things that we see around, only 9% of the water is actually other. Now, that is the surface water. Now, what are the surface waters made of? That is the third diagram. Lakes, about 87% of the surface water is concentrated in the various lakes, and 11% are in the swamps. Well, of course, the Florida Everglades is a good example. And 2% are in rivers and streams. And remember, most of our drinking water comes from here, rivers and streams. although we actually tap a lot of this groundwater. So this is a summary of all the waters that is available to us. So only about 0.3% of all the water on the earth are available as fresh water for humans. So that is where there is great need to conserve our water resources. Now, does it mean that the fresh water is in any imminent danger of being finished? Well, not really so. Why not? Because the freshwater supply is continuously being replenished and rebuilt by the hydrological cycle, the hydrologic cycle. We talked about the hydrologic cycle in a former lesson. What is hydrologic cycle? The evaporation from the sea produces condensation and precipitation, which brings rain to the surface, which then produces runoff and produces streams and rivers. So the freshwater supply is actually continuously being replenished. Now, we should be concerned once that rate of replenishment is slowed down. Now, when will that happen? When we don't have enough rains, is that right? Now, this year, Florida did not receive as much rains as we normally receive. That means we are actually using up more water than the supply gets replenished. And there is a danger that we might run out of water. So there is generally abundant supply of fresh water because of the continuous replenishment due to the hydrologic cycle. Well, let's look at our freshwater supply. The basic source of fresh water is precipitation. You see, the evaporated water from the sea condenses and we get rain. And that rain and snow and all that kind of thing. So basic source of fresh water is precipitation. Now, not all precipitation add to the freshwater supply. What happens to most of the precipitation? More than 2/3 of the rain eventually returns to the atmosphere due to evaporation. Well, most of the water that falls on the surface of the earth returns as precipitation, and well, of course, a part of that comes back. And that is the cycle that keeps on removing and replenishing our freshwater supply. Some of the remaining run downhill. You can see Florida, you don't see a lot of runaway water. But if you go to hilly places, most of the rain that falls on those areas run down the slopes and flow into streams and lakes, into rivers and into the sea. So some of the remaining run downhill across the surface of the land, and others get soaked in. And what happens to the soaked in water? It is the soaked in water that actually forms our underground water resource. That is the groundwater. Now, water moving across the surface is referred to as runoff. Now, especially farms are actually affected by the runoff. The hilly areas, the runoff will actually cause the erosion. Is that right? When water runoff, it carries with it the debris and the soil and everything else. The runoff water eventually forms streams and rivers. You can see, you are familiar with these kind of situations. These rivers are actually water that gets runoff from various parts of a locality, which gets collected and then forms a stream, and small narrow streams join together to form big streams, and the big stream will then join into the river to become a big body of water. And these are things that we are generally familiar with. Alright, soaked in water is the source of groundwater. So water that gets runoff, this water that falls on the surface that forms the runoff will eventually become streams, rivers and lakes. That is the surface water. And the water that is soaked in is the source of groundwater. Now, groundwater sometimes feeds streams so that they continue to flow. If you go into hilly areas, you can see streams starting from the foot of the hill. Now, I come from a place which is actually full of hills and valleys, and there are many streams that originate from the foot of the hill. In fact, a lot of homes get their drinking water from such streams, beautiful fresh water. And these streams are actually fed by groundwater underneath the hills. So groundwater sometimes feeds streams so that they continue to flow. Now, streams very often constitute the origin of a river. If you go upstream on a river and to look for where does this river originate, you probably will end up at the foot of a hill where you have 2 or 3 narrow streams, and gradually these streams, one adding to the other, these runoff water will eventually make a big river. So streams very often constitute the origin of a river. The amount of water that becomes runoff or groundwater. Now, what are the factors on which the amount of water that becomes runoff or the amount of water that gets seeped into the soil depend on? Well, you can say if the ground is too steep, most of the water will run off. If the soil is flat and not very dry, most of the water will get soaked in. Is that right? Let's put down some of these types. The type of soil. Now, if the soil is clay, it gets caked in very fast. That means there will not be a lot of water absorbed in. What type of soil will absorb and soak in water? Well, grainy soil that contains a lot of sand. Is that right? So the type of soil will indicate whether the water is going to run off or get soaked in. How dry the soil is. If the soil is very dry, rock dry sometimes, when water falls on it, most of it will simply dry off. Only a very little of it will get soaked in. Third, the amount and type of vegetation. You see, a lot of trees in an area will make the ground very hard by having their roots all over. Now, such an area will produce a lot of runoff. The soak-in will be very limited there. So all these will determine how much of water runs off and how much of water gets soaked in. And of course, the steepness of the slope. A very steep, hilly area will have a lot of runoff and very little soaked in. How about surface water? What are the sources of surface water we talked about? Well, streams, rivers, lakes, and so on. Now, streams eventually merge with streams until they form a major river. If you inspect, say, any of the major rivers, you can see as you travel down a river, you can see the tributaries, the streams coming from various places and feeding into the river. The river gets bigger and bigger as it flows down. In many cases, a river starts as a very small stream way up in the hill. And then as it flows down, it collects more water, becomes a big expanse of water. Now the land area strained by a stream is known as the stream's drainage basin or the watershed. You see, if you look at a particular location, and if there are streams flowing down, the basin where the streams does the drainage is actually the watershed. Now, look at the Chesapeake Bay watershed. Now, this is an area where streams flow into the Chesapeake Bay. So, all the streams and rivers into this area empty into this Chesapeake Bay. And therefore, this is the watershed. Now, what is a watershed? A watershed is an area of land that drains all the streams and rainfall into a common outlet. Now here, the common outlet is actually the Chesapeake Bay, or the mouth of a bay, or any point along the stream channel. Now, the common outlet can be a sea, can be a great big river, and in this case, it is the Chesapeake Bay. Now, sometimes ridges and hills will be separating two watersheds. Areas that are strained by streams are separated by hills. That means there will be one watershed on one side of the hill, another watershed, another part of the hill, draining into different locations. Now, that kind of a hill that separates two watersheds is called a divide. Now, the watershed consists of surface water, lakes, streams, reservoirs, and wetlands, and all the underlying groundwater. All that constitute a watershed. The water of streams, ponds, lakes, reservoirs are all put together collectively we call the surface water. And most of our water need is actually taken from surface water. And all of them serve as freshwater resources for us. Now, Peace River serves as the water resource for most of the counties in this area. How about groundwater? Do we use groundwater? Well, groundwater is a precious resource used in many parts of the world for many reasons, for agriculture, for building up the landscape. Now, if you go to Kuwait or Abu Dhabi, for Dubai, see, these are cities in the middle of desert. There's hardly any rain there. There's hardly any fresh water supply around. Now, where do they get their water supply? There are very green golf courses around. There are green vegetable gardens there. Where do they get their water from? Now, they get a lot of their water from underground resources, groundwater. They tap the groundwater supply. You can see a lot of fresh water. Most of fresh water is actually locked up as groundwater. Well, here I have an illustration of groundwater. If you would dig any part of the surface, you will reach the groundwater supply. Now you can see the line that separates the layer where water is available to the layer where water is not available is called the water table. Now, if you would dig a well, people will say, yes, we have hit the water table. Is that right? That's right. So, from the dry soil, we have now reached the soil which contains water. All right. Now, groundwater is water that is found in the cracks and spaces in soil, sand, and rock. So, if you dig underneath, there are lots of crevices and holes and spaces inside the rocks and soil which can actually store a tremendous amount of water. Now, what is the aeration zone? The aeration zone is the zone above the water table. Now, you can see the water table is the layer of the surface of the earth that is almost saturated with water. And the layer above that is the aeration zone. Is that right? And that is known as the aeration zone. Now, what is capillary water? What is the meaning of capillarity? Now, if I dip a paper into some water, now I have some water in the beaker, and if I now remove it, now I don't know whether you can actually see it, but if you look at this carefully, you can see water. I just dipped the paper at the bottom, and you can see water has actually seeped in. Can you see water has actually seeped in on the paper? That means the paper was only dipped to this level. Now, water gets seeped in due to the capillary process. You see, in paper and clothes, if you put a piece of cloth in water, water gets seeped in. You see, there are tiny spaces where water will simply creep in, and that process is called capillarity. You see, soil, the space between the soils is also very small, and when there is very small space, water tends to seep in there. Actually, it is due to a property called surface tension of water, and that is what contributes this. That means if you have water in the water zone, this is the groundwater, a lot of ground above it will be dry. But due to this process of capillary or the capillarity, water will be seeping in and wetting the ground above, and therefore trees and plants that are growing near water will actually get that water supply. You see, a lot of big trees can survive years without rain. Why? Because their roots will penetrate deep into the soil where capillarity has brought in water from the groundwater supply. So just above the water table, in the aeration zone, over here, this is the aeration zone, is the capillary water that moves upward and makes the soil wet over there. And that is a very useful phenomenon for plants and trees around. Now, this water can move slowly. The water that has been going up due to the capillary process actually can move in any direction. Now, if you look at this again one more time, well, I don't know whether you can see this. You can see the water on the paper has actually moved in all directions. Now, that is the specialty of capillarity. So, this water, due to capillarity, moves slowly in any direction from a wet particle to a dry one. So from the wet portion to the dry one, water will move. Now, what is the saturation zone? What do you think is the saturation zone? Saturation zone is the zone where water is abundantly available. So the portion that is saturated with water is called the saturation zone. In fact, the saturation zone is the layer that is below the water table. So this is the saturation zone. It means the spaces between pebbles and sand and soil are all soaked in water. It is saturated in water. The upper surface of the zone, often open to the atmospheric pressure, is what is called the water table. So water table is the upper part of the saturation zone. If you can break into the water table, you can then go into the saturation zone and take in water. In fact, a lot of our municipal water supply is actually taken from underground by digging wells into it and pumping water. Most of the lawn sprinklers in Florida works on wells that are dug deep until you reach the saturation zone. What is an aquifer? An aquifer is a storage device underground. In other words, anywhere water is stored underground is an aquifer. Is that right? Yes. So most underground water is found in aquifers or underground layers of porous rock that are saturated from above or from structures sloping towards it. That means these porous, the spaces in the rock get saturated by water flowing from above or water flowing through a sloping area into the aquifer. Now, they get saturated by supply of water by these various sources. Now, there are two types of aquifers. The first type is called confined. What does confined means? Confined means it is closed by something. So confined aquifers exist where the groundwater system is between layers of clay, dense rock, or other materials with very low permeability. Now, suppose you have let me see if I can show that to you. Now, suppose this is the aquifer over there. Now, on top, there you have a layer of clay or dense rock of low permeability. What is the meaning of permeability? Now, a substance that allows water to go through is a substance of high permeability. You see, permeability is the ability or it permits to pass through. Low permeability, a substance of low permeability will not allow water to pass through. So these aquifers, confined aquifers, exist where the groundwater system is between layers of clay or dense rock or other materials with very low permeability. That means water inside will stay there for many thousands of years because they don't get out very easily because of the low permeability of the lid or the separation layers. Now, water in confined aquifers may be very old, arriving millions of years ago. They are stored in there, and very often if you can break into a confined aquifer, you can get large quantities of water. Now, what is unconfined aquifer? Unconfined aquifers are more common and do not have a low permeability deposit above it. That means they are much more accessible. They are much more readily accessible than confined aquifers. Now, what that means is that water in these unconfined aquifers will be relatively new. Is that right? Whereas the confined aquifers, water will be millions of years old. So water in unconfined aquifers is often considered very young in geologic time. When you say young, it is not 20 or 30 years, but in terms of geology, it is few millions of years. The top layer of an unconfined aquifer is the water table. So the diagrams I have been showing you, the layer below the water table is actually an unconfined aquifer which doesn't have a rock layer in between. Now the water table separates the saturation zone from the unsaturated zone. That's the unsaturated zone and this is the saturated zone. So if this layer normally is not a low permeable substance, then this will be a confined aquifer. On the other hand, if the separation between unsaturated zone and the saturated zone is very hard clay or rock, then this will be a confined aquifer. Now, water in aquifers is brought to the surface naturally through spring or can be discharged into lakes and streams. In fact, a lot of lakes and streams are actually fed by water that is in confined or unconfined aquifers. You see, streams are fed most often by water from the ground, from aquifers. And of course, lakes, for example, look at this surface water. There is a lot of this water is actually fed into that lake from this aquifer. So water in aquifers is brought to the surface naturally through a spring or discharged into lakes or streams. That happens very often. And we also go into the aquifers by drilling into it. Is that right? Yes. So groundwater can also be extracted through a well drilled into the aquifer. Now, I remember the place where I come from, we used to dig deep wells, about 400 feet or so. Then you got to dig through rocks. That means you're going to go into confined aquifers to get that big supply of water. So you can pump water from these aquifers. An artesian well does not require a pump. What is an artesian well? You see, underground, sometimes these underground waters are subjected to great pressure. So if you dig a hole or put a pipe through from the surface, the water will naturally come up due to that high pressure. Now that is called an artesian well. You don't need any pump. You need only drill a hole and put a pipe in there. Water will automatically come up. Now groundwater is replenished, of course, by rain and snow. So as we said earlier, as rainwater falls, a lot of that gets soaked in and then replenishes the crevices and the aquifers underground. So as we keep using groundwater, it is getting replenished. Now Florida is very sensitive about groundwater. You see, our groundwater is very precious. What happens is, if our groundwater level falls too low, because the sea level is low, the groundwater will get then replenished by seawater. And you can see you cannot use seawater for drinking and for agricultural purposes. So there is great danger if our groundwater gets very low. And that's the reason why our counties very often put out restrictions on water usage. So I hope most of you will heed to that restriction. I think all of you. It's very important for us because if you overuse this water, we are taking away too much water from the groundwater. That will take the level of groundwater low, which will allow the salt water to seep in. We cannot allow that to happen. So follow the instructions by the county. When it rains, turn off your sprinkler. Don't leave the sprinklers on during a rainy day, and only water the lawn once a week. Is that right? And if possible, grow native vegetations rather than trying to grow a lawn with waters that are not available. All right. Groundwater is a hidden resource and we need to conserve it. Groundwater accounts for 95% of all fresh water on the surface. Now, approximately 50% of Americans obtain all or part of their drinking water from groundwater. And nearly 95% of rural residents rely on groundwater. If you go from the metropolis to the rural areas, all households are actually supplied by groundwater by digging the well. Anywhere, if you go into New York and any areas, if you go into the suburbs, you can see people use water from the well for their fresh water needs. About half of irrigated cropland uses groundwater. Most of that big vegetable farms in California and other areas use their irrigation. Where does the water come from? They take the water from underground. Groundwater is the resource for that. And approximately 1/3 of industrial water needs are fulfilled using groundwater. You can see groundwater is used in a wide variety of ways, and we need to therefore use caution. Is that right? We cannot let the level of groundwater fall below the acceptable level. We need to conserve the use of our water. Now, how many of you keep the water running when you brush your teeth? And how many of you leave the shower on when you soap? Well, all these things are important. You got to conserve water. Use only water when you need it. Do not waste water. About 40% of river flow nationwide depends on groundwater. If groundwater runs dry, these rivers will run dry. Now, what is the need for protecting groundwater? You can see the variety of uses that we have for groundwater. So if you contaminate groundwater, you are going to use contaminated water. Look, now, if you do things like this, use engine oil and other contaminants into streams and little ponds, that is eventually go into the groundwater system and pollute it. So contaminated groundwater is very difficult and expensive to clean up. Solutions can be found after groundwater has been contaminated, but this isn't always easy. So what is the easiest way that we can protect our groundwater? The easiest way is do not contaminate it. Do not use fertilizers on your lawn. All the lawn fertilizers are washed into waters that get soaked into the ground. You see, all these things contribute to the contamination of the water resources. The best thing to do is to adopt pollution prevention and conservation practices in order to protect groundwater supplies from being contaminated or depleted in the first place. Now, all of you doing this course should make this a mission to educate people around you for the need for protecting our water resource. You see, our civilization, the existence of our civilization depends on our water resource. We've got to respect and conserve it, all right, for our future generations. Now, what are some ways to protect and conserve groundwater? First of all, dispose of chemicals properly. Almost every county has got their own recycling program or disposal program for the poisonous chemicals like batteries, engine oils, and so much other contaminants. So use those facilities. Don't throw things in the streams and lakes and water. Take used motor oil to a recycling center. Limit the amount of fertilizer used on plants. I would say you shouldn't even fertilize your lawn. I know a green lawn is very attractive, but you don't know the damage you do to the environment and your waters by using 2 or 3 times. I know there are people who fertilize their lawn 3 times a year. Take short showers. Do not stand under the shower for an hour. Now, shut water off while brushing your teeth. I told you that in the beginning. Run full loads of dishes and laundry. You see, that will not only conserve water, it will conserve electricity as well. Now, check for leaky faucets and have them fixed. Some of you might say, well, it's only one drop dripping, drip, drip, drip. But let it drip for a month. How much water are you losing? It is not only the question of paying for it, but you are wasting a valuable resource. So you got to act responsibly about conserving our resource. Water plants only when necessary. Do not open the hose pipe and leave it under a tree and go away. All right? Water only when necessary and to the minimum amount required to keep the plant growing. Turn off sprinkler system when it rains. And get involved in water education. Now, you as science students has a responsibility to educate others. And it is a collective responsibility of all of us to conserve our resources. All right. Fresh water as a resource. Fresh water is a terrific resource for us. Water is an integral part of the ecosystem. It is a natural resource as well as a social and economic good. You know that water is traded in. There are counties that fight over water. There is fight between Charlotte County and DeSoto County for water. It is an economic good. Is that right? Yes. In America, domestic consumption amount to 570 liters per day, per person. Now, this is actually person, not person. All right? 570 liters per person a day. That's a lot of water. Do you know that there are places in the world where people cannot even get 1 gallon of water per person a day? I have lived in places where people go 2 or 3 miles trekking with mud pots and carry water on their heads for their daily needs. So how much of water a couple of people going 2 or 3 miles can bring for their use? Now have a guess. Now, living in a country like America where natural resources are abundant, we should not only be thankful for our resources, but must be responsible for protecting it and saving it and conserving it for our generations to come. Now, this is only 10% of our total water consumption. This 570 liters per person is for your shower and your cooking and things like that. It's only 10% of the total water consumption. Remember, most of the water are used by farms and industries. 40% of it is used in agriculture. So when you buy a loaf of bread, you can see how much water is involved in the making of that loaf of bread. 40% is in the production of electricity. When you turn on your light, you should understand that a lot of water is involved in the production of that electricity. 10% used in industrial purposes. And most of the water supply come from surface water resources of streams, lakes and reservoirs. 37% of municipal water supply come from groundwater. So all these are ways we use our fresh water resources. Well, let's now spend a few minutes talking about how to make water ready for consumption. We all turn our taps and fill our glasses and drink the water. Where does that water come from? Now, how do you know that it is fit for consumption? All right, do you ever doubt about it? Surface water contains more sediments, bacteria, and possible pollutants than groundwater. You see, groundwater, you can actually dig a well into an aquifer, take water and drink it. It is almost clean water. But surface water, and we depend on this county, Charlotte and Lee and DeSoto, all these counties are using surface water. It contains sediments, bacteria, and other possible pollutants. Now, surface water requires filtering to remove suspended particles, treatment to kill bacteria, and processing to remove dissolved chemicals. All these need to be done before water is distributed for consumption. But groundwater is naturally filtered and is relatively free of suspended particles. Processing or treatment is not necessary for groundwater. Many areas where people get their water from wells, they don't treat it. But that water contains a lot of calcium and iron dissolved in it. So that water is, we call, what is it called? Soft and, well, heavy water, or something that contains a lot of dissolved materials is actually called hard water. Is that right? Yes. So most of the water you get from wells are hard water. Now, but it contains more dissolved minerals and make the water very hard. Now, one of the characteristics of hard water is that soap will not dissolve in it very easily. Groundwater is more expensive as a resource because it needs to be pumped up. It costs a lot of money, is that right? Now, the first thing in treating the water is screening. The first step in purifying surface water is to remove large debris like sticks, leaves, trash, and other large particles which may interfere with subsequent purification steps. And the second part is called coagulation and flocculation. What is that? Now, together, coagulation and flocculation is a traditional purification method which work by adding chemicals called coagulants that will effectively glue together small suspended particles. You see, when these suspended particles are very small, they will not settle. Now, these coagulants will help to glue them together. When they are glued together, they become big and heavy and they sink to the bottom. And that is a good way to remove them. So coagulation is an important step. Particles that are joined together are called flocks. When you add coagulants to water, these small particles, suspended particles, get all glued together, and then the glued together particles are called flocks. They are heavy and will sink to the bottom. Here you can see that illustration. the addition of coagulants has resulted in the formation of flocks, which then settle to the bottom of the tank. And you can take the clear water. The clear water is taken at the top, and the sludge or settled material can be removed from the bottom. And this process continues. So water is allowed to come into the tank where coagulants are added, and it is allowed to settle for the flock, and clean water is taken out. Well, it is not quite clean yet. You've got to now go to the next stage, which is the clarifier. Now, water exiting the flocculation basin, this is the water, goes into the sedimentation. In other words, it is then allowed to stand for a considerable length of time for all the flocks and other materials to settle down to the base of the basin. And then it has to go through filtering. You see, sedimentation will not remove all suspended particles. You got to now take this water through filtering. Now, after separating most of the flock, you cannot remove all the flocks. Water is filtered as the final step to remove remaining suspended particles and unsettled flock. And what is the filtering process? The most common type of filter is a rapid sand filter. Now, water moves vertically through sand. Now, here I have the illustration of a filter. There are different stages in a filter. Water moves vertically through sand, which often has a layer of activated carbon. If you look at the top here, this is anthracite coal. Now, when water is passed through that, it will remove a lot of harmful dissolved chemicals from the water. It's a very important process of filtration. And then it passes through sand and gravel. You see, so that anything that is not removed will get absorbed in the sand and gravel, and you can get purified water. The top layer removes organic compounds that are chemicals, which could include dangerous disinfection byproducts as well as those with taste and odor. All those things get removed at the anthracite coal, and then water goes through the filtering process through the sand. Now, here I have shown the sand part one more time. How sand actually helps, which is mechanical and physical straining. As water goes through, the space between, you know that the space between sands is very small. The space between sands and pebbles will trap these very minute particles and flocks, so that when water completely going through the sand and pebbles will get rid of all these suspended particles. Well, this is one more time. Once you used the filter, you need to clean it. You see? Now, in order to clean it, you allow water to go into the inlet here and take away all the accumulated sediments in here and clean out, so that the filter is now ready for use again. Alright. And finally, you got to do disinfection with aggressive chemicals like chlorine to kill bacteria. So those are the important steps. What are the steps again? The first step is screening, to remove big pieces like wooden sticks and leaves and other things. Then you go into the coagulation and flocculation stage. Then you go to sedimentation stage. Then you go to filtration stage, and finally disinfection. And now the water is ready for consumption. You can see water will contain all kinds of bacteria, And before it becomes ready for consumption, you need to disinfect it. Chlorine gas and sodium hypochlorite are most commonly used disinfectants, and they are effective in killing dangerous bacteria and other organisms. And very often, those who use good filters at home actually removes that chlorine before you actually drink it. Otherwise, we will be consuming a lot of chlorine that is dissolved in the water. Now, distilling and reverse osmosis are other ways to produce clean water. Now, distilling is taking, say, seawater, boiling it, and making vapor out of it and condensing it back to water. A very good way, but a very expensive way. It's not really feasible. And reverse osmosis is practiced in many, many cases. In fact, a lot of water in the Middle Eastern countries is obtained by desalination process. What is desalination process? Desalination is the process of removing salt from water. Now, the ever-increasing demand on the surface water and the dwindling supply of groundwater raises serious questions about conservation and who should have priority of water use, industry, agriculture, or domestic use. These are questions we need to answer as we go on. Now, a practically unlimited supply of fresh water could be available by desalting seawater. It's a very expensive process. Here, this is a desalination plant actually in Tampa. There is a plant in Tampa. The Tampa Bay Seawater Reserve is the reverse osmosis process that produces about 25 million gallons, 95,000 cubic meters of water per day. But that's only a very, very small part of our water need. The plant holds 40,000 membranes of elements 32 reverse osmosis and uses optimized multi-stage RO and boron removal procedures. This is technical terms used for removing dissolved salts and minerals from water. The membranes are used for removing these dissolved salts. Very expensive process, but maybe that is a long-scale solution for our problem with fresh water. Now, lastly, let's talk briefly on the wastewater treatment. Now, it is very important that the wastewater we throw away from our homes needs to be treated before it is dumped into local streams or lakes. Is that right? It's very important. Now, wastewater is used water. It includes substances such as human waste, food scraps, oil, soaps and chemicals, and in homes that includes water from sinks, showers, bathtubs, toilets, washing machines and dishwashers. In business, it includes the water that is used for various business purposes and so on, and all that is wastewater. And if you can clean it and reuse it in some other purposes like watering your lawn, for example. Why treat wastewater? Because clean water is critical to plants and animals that live in water. This is important to the fishing industry, sport fishing enthusiasts, and future generations. There was a time the river water Thames was so polluted, no fish will even grow in it. And the municipal council in London actively went on a cleaning activity, and now the river Thames is now back in its glory. In other words, a lot of industries are no longer allowed to pour their waste into river Thames. They should clean it before pouring it. Now, all these cleaning process is very important. So, if it is not properly cleaned, water can carry disease, And since we live, work and play so close to water, harmful bacteria have to be removed to make water safe. Now here I have shown some steps of used water treatment. Now here is the used water coming in, and the first thing is screening, removing big substances from it. The next thing is aerating in an open basin so that the sludge will settle down, and remove the sludge. And removing the scum, all that sludge is removed, which is processed and goes into farms for agriculture, for manure and so on. And the water is trained in, and you treat it for bacteria and then pump it into streams or lakes, and then it is clean, it is harmless. And this is the way to protect our groundwater, our surface water, which is very crucial for healthy life. So I hope you have a fair understanding of water and the need for preserving, conserving, and make sure that our water is protected from contamination.